Welcome to York Universe, the astronomy and physics podcast written and presented by the students, faculty, alumni, and friends of York University. You'll now find us wherever podcasts are distributed. I'm Paul Mackin, one of your hosts this evening, and I'm joined by my colleague Suna Withers. We're both affiliated with the Department of Physics and Astronomy here at York University. Tonight, we're broadcasting live from the Allan Carswell Observatory on the Keele campus in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal time at York U Observatory. We run in concert with our online public viewing, or as we call it, the OPV feed, run by the observatory staff, and we have good skies this evening. They will be sharing some live and some archival images and answering your questions in the simultaneous YouTube chat. To follow our live show or learn more about us, please visit yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. For any questions or comments about past shows or suggestions for future topics, please email us at observe@yorku.ca. You can also connect with us on Instagram at YorkU Observatory or on Facebook at Allan I Carswell Ob. All of our programs are free, but if you'd like to make a donation, we would certainly appreciate it. Please see our website at yorku.ca/science/observatory. We will be monitoring the YouTube chat for questions and post content. How are you doing this evening, Suna? Getting any observing in?
Yeah, I'm doing pretty well. We've had a couple of good nights. We've had both the 60 and the 1 meter running a couple nights last week. So the weather has actually been pretty good for observing. I see you're also getting a lot of astrophotography in as well.
I am. Most of the research work I'm doing now is more related with atomic physics, but nothing will change me from being an amateur astronomer. So,
Yeah.
the degree would be in from the Department of Physics and Astronomy. So I think it's 6 of one, half a dozen of the other, in a sense. But yes,
Always an
no, the
astronomer.
skies. Yeah, absolutely. The skies have been great lately. The weather's getting warm. Of course, it's starting to get dark quite a bit later. We'll talk more about that in a bit. But I'd like to take a minute starting off tonight to talk about the sky at night in June. So looking out my window right now, I can see just the western horizon above some trees. And in the west, right now, Venus and Jupiter are making a lovely pair just after sunset. Now, Venus is fading a bit and it's sort of moving closer to the sun where it will remain for a few months. But Venus is going to continue to rise and higher in the sky. And Venus is by far the brighter of the two and is really easy to find. Look around about 30 minutes after sunset with a clear western horizon, and you should see both. Venus is going to be very bright, Jupiter less so, and slightly closer to the horizon. For the next week or so, this will be a stunning pair as they're quite close together. But then they'll be joined by a third planet, which is the elusive Mercury. And we're, as we transition next week into a mini planet parade, which is Venus, Jupiter, and Mercury. And it's taking place, in the western sky in June, which is where we are now. The trio will cluster together closely shortly after sunset and remain visible to the naked eye around the middle of the month. Mercury will be most visible next Monday as it reaches its highest point above the western horizon. Even then, though, Mercury is difficult to spot. I think I've seen it a couple of times through a telescope, but I've only ever seen it once or twice with the naked eye. It's hard to find. You need to look very low in the sky, west, about 45 minutes after sunset. There are some great web tools to help you find Mercury, but a clear western horizon right down to the horizon is key because it never gets very high up. Also tonight, the moon is in the third quarter, which means that it rises in the east around midnight, and it's at its greatest elevation towards the south around sunrise. The moon will be new on the 14th, the first quarter on June 21st, and the strawberry moon, which is the new moon, what we call the full moon this month, rather, um, happens on the evening of June 29th. It gets the name from Native American Algonquin tribes who used to use it as a signal that June-bearing strawberries were ripe to be picked and harvested, wild strawberries. Um, so that's the moon. Now, of course, we can't discuss June skies without mentioning the sun. In this case, the 2026 summer solstice, which falls on Sunday, June 21st. Now, the week that it happens, we'll no doubt mention it in our podcast as well. But it's going to occur about 4:24 in the morning, Eastern time, and that will mark the longest period of daylight for the year and the official start of astronomical summer in the Northern Hemisphere. The good news is that it marks the beginning of summer. The bad news is that after June 21st, the nights start getting longer again, which is great if you're an astronomer and want to observe, but less great if you're a summer sun fan. As for the other planets, well, Saturn is a bright yellowish white object in the pre-dawn sky. I think it's about magnitude 0, shining in the constellation of Pisces. And it is pre-dawn, so it'll stand out quite well. It's the brightest point of light in that region of the sky and offers excellent viewing opportunities as it climbs higher before sunrise. You will be able to make out that it is not spherical. In a pair of binoculars, it'll look kind of oblong, and then or elliptical. But if you look at it even through a small telescope, you should see the rings, which are still relatively edge on to us, but you'll be able to make them out. Mars is early morning celestial sight, transitioning from constellation Aries into Taurus by June 20th. It's not that bright. It's 1.3 magnitude, and it's not particularly large in a telescope right now. But it is there, and it's quite lovely. It's got a distinct color, as you'd expect from Mars. And if you're an early riser, you can see it. I will say that Mars is always, to me, one of the most disappointing objects because it's not that bright. Not that bright, and it's not that big. But get a spacecraft close to it, and it's amazing. So, Mars is one of those places that you probably have to visit robotically, but I've often found it a little disappointing through a telescope. I am going to try and image it this summer, though, so we'll see. In terms of deep sky observing, June is prime season for viewing the luminous center of our galaxy, the Milky Way. So remember that we're a star on the disk, I think about 1/3 of the way out from the center. I'm not sure if it's are we 1/3 of the way out or 2/3 of the way out?
My guess is 1/3 of the way.
Yeah, I think we're about 1/3 of the way out. And there's a lot of dust and other things preventing us from seeing the actual core of the galaxy. But we can get some hints of it. And if you look towards the south in the summer, you're going to be seeing in that direction, and it is noticeably brighter. Where our image for this week's podcast is actually that of the galactic center as seen from Alberta. So the galactic core rises in the southern sky around midnight and shines brightly through the night. For clearest views and the best photography, target the moonless window around June 15th to avoid lunar light pollution. But this is a great one for many of our provincial parks, deep sky preserves, or for trips to the cottage. Now, heading in the same direction, I'm going to plug two of my favorite nebula for Canadian skies. They show themselves in the south this time of year. The Lagoon Nebula, M8, and the Trifid Nebula, M20, are visible with modest telescopes or binoculars if you look south in the June night sky. So we're heading into kind of the best time for observing because it's warm. You don't have to bundle up, and we all go to, or a lot of us go to cottages or go away camping or whatever. And just even taking a pair of binoculars with you, or a couple of weeks ago we talked about inexpensive smart telescopes, gives great opportunities to get some real observing in. And Suna, are you going to Killarney this summer?
Yeah, Anna and I are going to Killarney on June 19th. So we're gonna miss the moon-free period, but as you said, we it puts the galactic center in like the perfect spot for us. So we spent a lot of time around Sagittarius last year when we were there imaging kind of that area. So I think the plan is to try it again this year. But yeah, if you're in Killarney Park at any point this summer, there's a lot of astronomers and residents who are going to be out there. So definitely keep an eye on the event schedule. We'll do things like they have two telescopes out at Killarney, so we open those up and do live viewing. There are constellation tours, and even just any astronomy talks. So if you have questions for astronomers, you can just come by and ask questions. And we're always happy to chat about astronomy.
And in June, of course, the mosquitoes will not be at their worst. So
Yeah.
um, it's a good time to go.
Yeah.
And just around the time school gets out, so take the kids, go up there and meet Suna and the gang,
Yeah.
and learn and see the core of our galaxy.
Yeah, and
Um,
Killarney is a beautiful park as well. There's lots of nice hiking trails and other activities you can do at Killarney during the daytimes as well.
Fantastic. So, Suna, let's switch over to this week in astronomy, and you've got something from this week a few years ago.
Yeah, so June 13th, 2010, which is the return of the Japanese Aerospace Exploration Agency, or JAXA's Hayabusa mission, which was the very first sample return mission from an asteroid. Now, Hayabusa spacecraft launched in early May of 2003, and the name Hayabusa comes from the Japanese word for falcon. Now, like I mentioned a second ago, this was the very first sample return from an asteroid that has ever taken place. So the mission goals for Hayabusa were sort of twofold. One of them was, of course, all of the amazing science that's going to come out of visiting an asteroid and actually returning a piece of that asteroid for analysis to the Earth. But this was also partly a technology demonstration and JAXA just doing something that had actually never been done before, which has kind of paved the way for a lot of the other missions in kind of in the solar system. The one that I think of most clearly is NASA's OSIRIS-REx mission from a few years ago that returned a sample of the asteroid Bennu. No doubt the Hayabusa mission kind of helped understand the engineering and that would be involved in missions like OSIRIS-REx. But um, anyways, the Hayabusa mission visited asteroid which was named 25143 Itokawa, which is a near-Earth asteroid. It had the rendezvous with this asteroid in September 2005, where it started to map what the asteroid looked like, in which case it discovered that the asteroid is kind of peanut shaped and less than a kilometer in size. In size, less than a kilometer in size. Now, before doing the actual sample collection, the Hayabusa mission had planned to do a test lander deployment, which was the test lander being called Minerva, where it would just sort of hover over the asteroid in orbit, launch this little test lander to kind of see what this sort of touchdown and later takeoff from the surface of that asteroid would look like. Unfortunately, Hayabusa was a little bit too high altitude when it deployed the Minerva lander, so the lander kind of just like floated off into space and didn't actually touch down on the surface of the asteroid. But the mission was still a success because, again, this was just a test lander to lead up to the actual sample collection mission, in which case there were two actual attempts to collect a sample, both in November 2005. The first time Hayabusa was able to land on the surface, stayed there for 30 minutes before it took off again from the surface. And then the second time it did basically the exact same thing, trying to collect a sample from the surface. Neither time did the Hayabusa spacecraft actually deploy its sample collection mechanism, which were called these sampling bullets. It was a little bit of a mystery about whether or not these sampling bullets had been deployed on the second attempt. The first attempt, I don't think they had actually like really planned to deploy them, but the second attempt, they were trying to deploy them, and it was a little bit unclear whether or not they had actually deployed. But later data suggests that they didn't actually deploy as planned. Nonetheless, during all of this process, Hayabusa had kicked up a lot of sort of dust and particles and other stuff from the surface of this asteroid. It's only a 1 kilometer in diameter asteroid, so it's pretty easy to sort of like knock a whole bunch of stuff out of the surface and into space that the sampling bullets can later kind of collect. So it was able to still collect a sample of this asteroid, even if the bullets didn't deploy the way that they had been planned to. But Hayabusa returned to the Earth on June 13th, 2010, and it landed in Australia with a sample of 1,500 grains, which was the very first time humanity has ever collected a sample of an asteroid and brought it back to the Earth. And one of the really remarkable things I should note about this mission is that it was a success despite a lot of problems. The spacecraft in particular had issues with a fuel leak and a months-long contact loss with the Earth. But the mission was still able to accomplish all of its major science goals and give humanity the first look of what an asteroid actually looks like. Now, the analysis of this sample showed that the asteroid had a very similar composition to a lot of meteorites, and that it was likely part of a larger asteroid before separating and becoming its own smaller asteroid. The sample is, of course, still being used today, as is the case with so many things in astronomy. People go out and get a little bit of data or a lot of data, and people just continue to analyze this for decades. There's just so much science that can be done with asteroid samples like these and other telescope observations. So the sample collected by Hayabusa is still being analyzed today. One of the more recent research papers that I found from the Hayabusa sample was from 2021, which showed that the composition of the sample supports the theory that the water was on Earth was mainly brought here through impacts through asteroids and comets. So a very interesting sample and a cool This Week in History item.
Oh, and I remember this mission, and I remember the fact that the spacecraft was thought to be lost. And a lot of people said, well, it was an engineering demonstration anyway. So, these things happen, but they got it back.
Mhm.
Actually, JAXA had success with a couple of missions like that. They had another Mars mission where if something failed to go into orbit, and they got it into orbit the second attempt a couple of years later. So they've been very good about that. Like they build really resilient spacecraft, and then of course they had Hayabusa 2, which also did a sample return. And
Yeah.
and as you mentioned, NASA's had its own sample return mission as well. But asteroid missions are great. I mean, we've got another one coming up, Hera, which is going to Dynamos and Didymos. I can't remember what it's called, Didymos, where they basically impacted a spacecraft into an asteroid, and they're going to take a look at it. It's actually an asteroid that's the moon of an asteroid, and
Yeah,
they
that was
noticeably changed the orbit. And now the European Space Agency is sending a spacecraft out to look at it. Another interesting thing about Hayabusa is it's an ancestor to an upcoming mission by JAXA, where they're going to use very similar techniques to Hayabusa 1 and Hayabusa 2 to return samples from Phobos, the moon of the aforementioned very more boring telescope object, Mars.
Oh man, I remember a few years ago when Mars was having one of its I'm blanking on the names, but It was kind of like the close approach to Earth, and the
Or it was an,
observatory.
yeah, it was an
Yeah,
opposition. It was an
yes,
opposition.
opposition. The observatory was running like a week and a half long event where we had observing on the atrium every single night to look at Mars. And it just so happened this corresponded with like one of those massive planet-wide dust storms. You couldn't see anything on Mars. It was
Yeah,
like it was a red disk, a small red
yeah.
disk in all through all of the telescopes. And like this is the time that you can actually observe like these great cool features on Mars when it's in opposition, it's close enough to the Earth that you can see this. And we couldn't see anything, and it was so disappointing.
I've got a Schmidt-Cassegrain telescope. It shows Jupiter beautifully. It shows Saturn really well. It's quite fair to Venus. And you know what? Mars is still a small red disk.
Yeah.
It's just that planet. It's got this great reputation, and it deserves its great reputation. But you have to send a spacecraft there to prove it.
Yeah.
So,
Yeah.
so
At least Venus looks like it has a little phase to it. So even if you
it
can't
does.
see anything on Venus, you can still see it looks like a mini moon.
Yeah, and
Pretty cool.
it's so startlingly bright when you see it. I mean, I'm looking out my window now, and I can see it. It's not even dusk yet. It's not fully dusk yet, and there it is, bright as anything. Can't see
Mhm.
Jupiter yet, but you can see Venus.
Yeah.
Um, so I'm gonna do a news story that's got a bit of a sad ending. Sorry to say, but on June 14th, 1949, the United States launched a rhesus monkey named Albert II into space from the White Sands Missile Range in New Mexico, making him the first mammal to travel in space. So you have to go back to the Second World War here. The Germans had the V-2 rocket, which was very toxic to London. Um, they had the V1 buzz bomb and then they had the V2 rocket. Now they didn't have a lot of them, but after the war, basically the Americans sent in their troops and the Russians sent in their troops, and they both basically kind of split up what they could find of the German rocketry program, including working rockets and some of the scientists. And famously, Werner von Braun was the scientist, the head scientist, man of a bit of a checkered past, I think you'd have to say. But he was brought to the U.S. and they brought several V2 rockets with them as well. They put them in White Sand at the White Sands Missile Range, which is still a working missile range in New Mexico. You can go there. I've been there, and you can actually see the museum, and you can see some of the rockets, and it's quite impressive. So they put this poor little monkey, on board an adapted V2 rocket. Um, Albert, well, let's just say Albert went out with a bang. He got to an altitude of 133 kilometers, but then coming down, the parachute failed, and Albert went boldly where no primate has gone before. He was an astronaut or an astro monkey before he went to meet his monkey maker. But he pushed past the boundary of the space environment, proving that life could endure an upper atmosphere environment if sealed in a capsule. So this was a giant leap for bioresearch because before humans could safely venture into the cosmos, scientists need to understand the effects of cosmic radiation and weightlessness, sorry, upon living organisms. The rocket uh, was utilized was Blossom 4B, which was a military surplus V2 rocket provided by the U.S. Army and Air Force. And the legacy is, though the mission ended in crash landing, the physiological data collected during the flight paved the way for subsequent animal tests, ultimately leading to human spacecraft in the following decade. And you have to look at history through a bit of a lens. Uh, uh, you can't look at it by some of the standards that we apply today, where we're very much against animal testing, uh, except in very controlled conditions. But apes went into space long before humans did. Uh, the Americans launched Ham before they launched Alan Shepard. Um, Sputnik 2 had a dog on it that also didn't survive. And they didn't really build in a lot of care for Latka, which was the name of the dog, and it died. It died basically as the environmental controls failed. Um, and Ham didn't have a great legacy either. He came down fine, and then a few days later had a heart attack, I think. But um, this is the part of the story of we built on how we got there, how we continue to get there. So I think we can be sad for Albert, but the world is probably a better place for his noble effort.
Yeah, I imagine that it must be such a stress to animals that get launched into space like this. I mean, it's stressful for humans who agree to go on these missions, but imagine being an animal and just having no idea.
Yeah, it's again, I part of me is I read the story and I remember when we were doing extensive animal testing in spacecraft and whatnot. I remember a lot of that, and this was monkeys are very good. Primates are good for other primates, and uh, so chimpanzees make an excellent human substitute because they're highly trainable. Their physiology is quite similar. Other primates, other monkeys work well too. So, um, but it is sad, and you know, but we live in a different world now with a different world view, and I think you have to be cognizant of the history of this as well. This wasn't considered unusual or even necessarily cruel.
Yeah,
Um,
there's also, reading about like the history of this and the reasons why they had sent these animals up in the first place. A lot of it was just nobody knew if humans could function in zero G. So it was really like the fundamental basic thing that we kind of know now, where it's like there's a lot of impacts to the human body and the way the human body functions in space. There's a lot of bad things that can happen, but we know, for example, humans can swallow food in space. We didn't really know that at the beginning in the early days of space exploration. And it's like
yeah,
these missions, as sad and horrible as they were, they really told us that the very basic fact that a living being can go into space in a closed container with life support systems and actually come back alive, which was not, it seems obvious now, but this was not really something that anybody knew at the time.
absolutely. In fact, there's a very good TV series called From the Earth to the Moon. And in it, in the very first episode, uh, basically a NASA employee lays out all the things they don't know about what will happen. It takes 2 weeks to go to the moon and come back. Can humans survive in space that long? You know, um, will their heart keep working? Will their heart be able to work after they come back? Can they swallow food? You know,
Hmm.
so these were all questions that had to be worked out. And if you look at the very first Mercury mission, it was 15 minutes up and down, very similar to this mission. The second one's the same. Third one, it was 3 orbits, so coming up on 5 hours. And they slowly expanded what they did. And when you got to the final Mercury mission, they were up there for a day. Okay. And then they got into the Gemini missions, and there they spent up to 2 weeks in orbit. Well, so they were starting to build up their knowledge base. And that's kind of how you do this, right?
Yeah.
Why is NASA so good at building spacecraft? Because they've been doing it for 60 years,
Yeah.
so anyway, we're at the halfway point. So I'd like to remind everyone that you're listening to York Universe, the space and astronomy podcast from York University. We are broadcasting live from the Allan Carswell Observatory at York's Keele campus in Toronto, Ontario, Canada. Please look at our website at yorku.ca/science/observatory to join the chat. Oh, if you have questions or want to look at some of our content. Tonight you're listening to Paul Mackin and Suna Withers. And right now we're showing some great archival images. Uh, uh, one of them is very familiar to me, but they're fantastic images, and I think I think. All right, I'll go ahead and say it. The middle one's mine right now. But anyway, so yes, Suna, we've got a couple of announcements. You had one on observatory tours.
Yeah, so we are running our weekly Wednesday observatory tours throughout the summer. At the moment, they are on alternating Wednesdays. So if you'd like to come and see the observatory, see both of the telescopes, and potentially do some live observing if it's clear, just drop by from 8:30 to 10:30 p.m. every other Wednesday. We do ask that you get tickets ahead of time. These tickets are free, but it's just so that we know who's coming and when. There is a limited space up in the observatory, so we can't just let a ton of people up at the same time. You could get those tickets from our website at yorku.ca/science/observatory. On the front page, there's a list of upcoming events, and there are links to the Zephy tickets up on the front page of the observatory. So please come by for some of the observatory tours. If you are around campus sometime this summer, we are also doing every now and then some pop-up astronomy events. These are a little bit more erratic than the observatory tours because we can't really schedule them too far in advance since we don't know what the weather is going to look like. But we did a little pop-up observing by the York U subway station the other day. We took a look at Jupiter and Venus in the earlier evening through one of our telescopes, and later on in the night looked at the Ring Nebula. So if you just keep an eye on our social media, we usually do give a little bit of a heads up when we're going to be doing these pop-ups. And if you're around campus, we'd love for you to stop by.
Absolutely, and it's a lot of fun when you go, and you should. It's a great activity for the summer, particularly. Also, a great activity for the summer is our I guess it's our second
Yep.
Astro Fair on August 29th. Tickets are $30 for it's a full day, and information is on our website. But just a quick highlight: we're going to have an indoor planetarium. There's going to be, if the sun sky is clear, we're going to be able to look at the sun. We're going to be with a solar filter on, of course. We've got telescopes and activities. We've got partners there, including the Space Place Canada, the University of Toronto's Dunlap Institute for Astronomy and Astrophysics, the Royal Astronomical Society of Canada, Toronto Centre will be there. So this is a lot of fun, and I would absolutely encourage you to come and join in that fun with us. Were you there last year, Suna?
I was, yeah. I won't be able to make it this year to Astro Fair because I have something else I have to be doing on that day. But Astro Fair was a lot of fun last year. The planetarium is a lot of fun, definitely.
Super. And,
Yeah.
sadly, I just noticed they tore down the McLaughlin Planetarium. It had been
Yeah.
closed for many, many years in Toronto. And of course, the other planetarium was at the Science Center, and that's gone too. So there are no planetariums in Toronto right now. Hopefully, there'll be one coming back. But if you want to come to a planetarium, come to the Astro Fair. Okay,
Yeah.
so let's move on to some astronomy and space news. Suna, you've got something on my second favorite telescope.
I think this is also ranks up the list for one of my favorite telescopes, even though it hasn't launched yet. So we have a good update on NASA's Nancy Grace Roman Space Telescope, which is that it is almost ready for launch. Now, before I get into the actual update itself, let me give a bit of a background about why this is, before it's even launched anywhere, why this is one of our favorite telescopes. This thing is going to be revolutionary for astronomy. It is often compared to the Hubble Space Telescope that we know and love, that has been operating in orbit for, it's got to be close to like 25, 30 years at this point. But it's often compared to Hubble because Roman and Hubble both have the same primary mirror diameter size, basically. And it's really the size of the primary mirror that determines really important things like how sensitive the telescope is. So the bigger the mirror, the fainter an object it can see, and also the resolution of the telescope. So a bigger mirror is higher resolution. Now, typically what you see with a lot of telescopes is when you have these really sensitive, high resolution mirrors, typically you're limited to a pretty small field of view. So you only look at a really small patch of the sky. And this is definitely the case for telescopes like Hubble and James Webb. These both have pretty limited fields of view, so you can only see something like a small fraction of the size of the full moon, just for example, with each of these telescopes at the same time. But for Nancy Grace Roman, it has the same size primary mirror as Hubble, which is 2.5 meters, meaning it can get really, really high resolution and deep images of the sky. But it has a field of view that's about 100 times larger than Hubble. So it's able to see really large portions of the night sky in sort of in a single shot. So observations that would take telescopes like Hubble and James Webb years to do, Roman can just do in a single shot. So it's going to be used for a whole variety of different kinds of science. In terms of galaxies and cosmology, it's going to be able to observe billions of galaxies only within the first couple years of its operations. By the time it has sort of completed its mission and its life cycle is up, it will have observed probably trillions of galaxies. And this will help to do a whole lot of things, including detecting galaxies in the early universe and also studying large-scale structure, which can help us understand things like dark matter and dark energy. So it's going to be completely revolutionary on the side of cosmology and galaxies. But Roman also is going to do a lot of work and a lot of science in terms of exoplanets. So it's not only going to be looking at galaxies, it's also going to be turning towards the Milky Way galaxy and mapping out a bunch of different regions within the Milky Way to look for evidence of new exoplanets. Not only that, it's going to have a special instrument on board, which is called a coronagraph. And coronagraphs are these really specialized types of instruments that you can use to actually directly image an exoplanet. So you're not just looking at, the influence that the exoplanet has when it's orbiting its star and evidence for it in orbit around the star. You're actually going to be observing the light that these exoplanets reflect off of their stars. And this is a really complicated type of observation to do. You can't use just any normal camera to get a picture of this. Even a lot of the advanced science cameras can't be used to do this. You need a really special type of instrument. And Roman is going to have the most advanced coronagraph that has ever been launched into space on board. So it's going to open up a whole new type of exoplanets that we can actually directly image. And it's going to teach us a lot about exoplanets as well. So overall, this is a very, very exciting telescope. And some good news out of NASA is that it has basically completed all of its testing and it has passed with flying colors. So right now, Roman is at NASA's Goddard Space Flight Center, where it's sitting in the clean room being constructed and now tested. The construction was completed back in April, and ever since then, engineering teams have been doing a whole bunch of different tests and inspections on the spacecraft, which included something that sounds kind of scary, and I think is kind of scary, which is the shake test. And this is exactly what it sounds like. It was literally just a test where NASA puts the telescope on something, shakes it like crazy to simulate the hectic launch conditions, and then basically just see if anything falls off, basically. Like, is there a loose screw somewhere that has allowed something to kind of jiggle loose? Did anything fall off of the telescope? They want to do things like this while it's still on Earth and repairable instead of just like launching it into orbit. And, if you have a problem after launch, if something gets shaked loose during the launch, no more telescope. The telescope can't function correctly. So they did this shake test among a variety of other tests, and recently announced that it has not only passed the shake test, so nothing got sort of shook loose or anything. The spacecraft is still intact, still working properly, but also that its mirrors and optical systems have remained perfectly aligned after the shake test, which is huge. Again, the mirrors and optics of the telescope do need to stay aligned after launch. There really isn't a process to do major corrections to the optics after launch. So it needs to be able to stay in like a very, very precise configuration despite all of this shaking. But that is really great news for Roman because it means now the next step pretty much is launching. It's currently scheduled to launch out of Florida on a SpaceX Falcon Heavy rocket on August 30th, which I should mention is about 8 months ahead of schedule. Absolutely awesome. And it's going to now be shipped off to Florida for launch. The August 30th launch is the earliest window that it can launch on. So it might end up being delayed by a couple of weeks, just depending on how the shipping goes, how the weather is looking in Florida. But nonetheless, it is still going to be months ahead of schedule. So very, very exciting. I cannot wait for Roman to start imaging the universe and the really cool pictures it's going to make. It's also going to be a really great opportunity to look for weird and unique objects. I'm always thinking of galaxies. So this thing is probably going to discover some really, really groundbreaking galaxies that you can then use the James Webb Space Telescope to further investigate in a bit more detail. So I'm definitely excited about Roman, and hopefully it launches on time on August 30th.
Yeah, it's fantastic. We really are in a bit of a golden age for instrumentation right now. You've got, of course, you've got Hubble and Webb; they're still going, and you've got. We're going to talk more about other telescopes in a minute, but then we're adding Roman to the mix. And then, of course, there is my favorite telescope, which is the Vera Rubin telescope. And the nice thing about this is all these observatories can work together on certain things, and it really is a great time to be, to be an astronomer because there's so much data coming in, more data
Yeah.
than we can possibly process.
So one of the things that NASA has been doing in the lead up to Roman's launch is actually coming up with new data handling systems. In the past, even with James Webb, it produces these really large mosaics where it mosaics a really large portion of the sky. Even with these images, like it's reasonable for somebody to just go onto the James Webb archive and just download the images and download catalogs and start doing science with them. The images that Roman is going to produce are way too large for that. Like it's just not feasible for somebody with like a regular good laptop to be able to actually download the images and data off this telescope. So NASA is also having to do a lot of work to literally just change the way that they handle the data and the way that scientists can access the data. So, oh, there's going to be so much cool stuff in this data set.
Yeah, as I said, it's an amazing time to be an astronomer, and of course we're having to learn, as you just said, ways to process the data. Vera Rubin, for example, a lot of AI agents are used on various different data streams, and they basically, if they see something, they alert other observatories and other interested groups to follow up on it. So instead of being basically a instrument which gathers data, it is an instrument which gathers and processes data, and Roman is following exactly the same strategy.
Mhm.
Um, Speaking of space telescopes, though, the James Webb Space Telescope weighed a sleeping giant black hole from 10 billion light years away, and it's 6 billion times our sun's mass. So black holes start to form at around eight solar masses. So your average mundane black hole weighs 8 times as much as the sun. This is bigger. Um, Using the James Webb Space Telescope, astronomers have weighed, and I put that in quotation marks, a sleeping giant, a dormant supermassive black hole located in a galaxy about 10 billion light years away. Now, what makes it dormant is that there is no matter really being pulled into it. So it isn't emitting, it isn't an active galactic core or anything like that. It's just sitting there. It's not really emitting any energy from basically its Schwarzschild radius. There's no matter falling into it for all intents and purposes. So the super this is the biggest black hole that scientists have ever measured. Now, most galaxies have that we know of have a supermassive black hole in their center, but this is a monster by even by those scales. So the supermassive black hole is located in the heart of galaxy. I love these names. MRG M0138, which is seen as it was when the universe was about 4 billion years old. And we now know that it weighs this 6 billion solar masses. Um, as I said, they can be conspicuous when they're actively feeding. Um, and that leads to something called an active galactic nuclei. Uh, but because of the black hole's gravitational forces, the active galactic nuclei, or the AGN, glows very brightly. Um, However, because black holes are surrounded by this light trapping boundary called an event horizon, dormant black holes uh, uh, basically, they're kind of like they have larders that aren't as quite well stocked, so matter's not falling into it, and they're practically invisible. Still, they do have a gravitational effect. Uh, and that influence can be seen in the motions of stars orbiting the black hole. And all those stars are visible. To detect and measure the mass of a supermassive black hole, the team behind this research used the James Webb Space Telescope to track the motion of stars around the heart of this galaxy. The star tracking trick has been used in the past to weigh dormant black holes much closer to Earth. Um, for example, a 4.3 million, that's three orders of magnitude smaller, supermassive black hole at the heart of our own galaxy, which is called Sagittarius A. However, Sagittarius A and its attendant stars are just 26,000 light years away. They're really close. And the most distant black hole with this technique, called stellar dynamics, has been used to weigh something out at about 700 million light years away, 15 times this previous record holder's distance. This new research is the first time it has been successfully employed to measure the mass, such a mass, at such a distant object. Um, so this is a big deal, and the team leader was out of the University College of London, a scientist named Richard Ellis. And he said in a statement, by demonstrating the feasibility of such techniques for the galaxies in the early universe, we can undertake more complex senses of how black holes develop over time and how they infer their role in shaping galactic evolution. And one of the questions I'd like to understand is, and I've spoken to some people who are specialists in this field, is how do supermassive black holes form? Because we don't really have a good explanation for that yet.
Yeah, that's definitely one of the like key issues with supermassive black hole formation at the moment. And yeah, I don't really have a satisfying answer for that. The one thing I will say is James Webb seems to have discovered a odd type of supermassive black hole, which are called little red dots. We've talked about them on the show, I think, a couple of times before, but they're called little red dots because that's essentially exactly what they are. They're just these really small, tiny dots that are very, very red. They had been really confusing everybody initially when they were first discovered because they kind of broke a lot of the models of galaxy formation, and it just took a little bit to kind of figure out exactly what these things are. But at the moment, it looks like the answer is they are just these very, very young, growing black holes that are kind of packed into this really dense cloud of gas, pretty much. And that combination of a young, growing black hole surrounded by a whole bunch of dense gas creates something that kind of looks like a black hole star. That's one of the names for them, which makes them very, very, very red. So we could literally be looking at like the earlier stages of supermassive black hole growth. I don't really know if these what exactly the going theory is on what these objects will turn into later. But I guess one of the things is they could turn into these eventual supermassive black holes later in the universe. But again, like this is still a relatively new sort of field of study, and we don't really, there's a lot of stuff that we don't know about supermassive black hole growth and also little red dots.
Well, you know what, Suna? It would be a boring world if we did know everything, I think. And part of our job is to learn stuff
Yeah,
and understand the universe around us. So if we understood
exactly.
everything, you and I would be out of our jobs. Um, okay, so Suna, you've got something else for us, another item, I think.
Yeah, so this one is a little bit closer to home, but still very far away, which is about two of the Milky Way galaxies, satellite galaxies, which are called the Large and Small Magellanic Clouds, or the SMC and the LMC. Now, these are basically two what are called dwarf galaxies, which are just very small galaxies that are currently in orbit around the much, much larger Milky Way. And as the SMC and LMC orbit the Milky Way, they do interact gravitationally with the galaxy, which can do a whole bunch of random stuff to both of the galaxies. There's a lot of sort of gravitational tidal interactions that happen where stars and gas can actually just get removed from those galaxies, and it ends up leaving behind what are called the Magellanic streams of gas and stars that have basically been pulled out of these galaxies by the Milky Way galaxy. Now, there's some new results that came out of a telescope in Chile, the Vista telescope, which has been monitoring both the large and small Magellanic clouds for a period of around 11 years. So they can really track the longer term motions and dynamics of the stars within the LMC and SMC to see their sort of how they're moving and what patterns there are in the motions of those stars to see what is kind of the driving force that's moving stars around in these galaxies. Now, for larger galaxies like the Milky Way, these all have these are all kind of rotation-driven systems where the main motion of stars around the Milky Way is like literally a rotation around the galactic center. And in the LMC and SMC, that might not necessarily be the case because these are much smaller than the Milky Way galaxy. So the dynamics in these systems could be very different. Now, results from a few years ago on the LMC show more or less what everybody had been expecting from the LMC. But there are some more recent results about the SMC that just look very weird and are not at all what anybody had been expecting to see out of this, which is that the motions of the stars from within the SMC indicate that the LMC has also been kind of wreaking havoc on the stars within the SMC and is actually pulling some of them out of the SMC. So the Large Magellanic Cloud is playing a pretty important role in essentially destroying the Small Magellanic Cloud. Now, based off of the current motions of stars within the SMC, astronomers estimate that the SMC's shape has changed a lot over the course of the past few billion years. So it's kind of this sort of fuzzy, stretched out sort of mess at the moment. But it was estimated that based off of the motions of the stars within the SMC, and you can kind of see what the motions of the stars look like right now, the distance from the LMC and from the Milky Way, and you can simulate it and sort of roll the clock backwards. And you would expect that the SMC was probably a lot more smaller and more compact, and I guess more ordered in the past than it is today, after there's been billions of years of both the Milky Way galaxy and the LMC kind of tugging on it and pulling some stars out of the galaxy. So I think these are really cool results. It really changes our idea of what the SMC looked like in the past and its longer term evolution up until now. It also could change some ideas about what's going to happen to the SMC in the future. Both the large and small Magellanic clouds over the course of the next few billion years are going to merge with the Milky Way galaxy. There's a lot of time in between then and now. So there's also a lot of other opportunities for both the small and large Magellanic clouds to change their shapes again, which seems pretty cool.
Yeah, it's interesting because we're also looking at a merger between our galaxy and Andromeda,
Mhm.
and the end result is going to be a big elliptical galaxy, which
Yes.
fascinating, but not particularly interesting to look at. They're big balls, right?
Yeah.
Yeah. So someone asked me the other day, what happens when two galaxies collide? And the good news is that galaxies are mostly empty space. So, you know, we're probably the sun itself, if it's still around when this happens, I guess it will be. We'll probably survive, but yeah, it's fascinating, and I've been fortunate that because I've traveled a bit in my career, I've managed to see both the large and small Magellanic Clouds, and they're quite lovely actually.
Yeah, that's
Um,
definitely on my bucket list is to actually see the SMC and LMC, but have
there,
to go to the southern hemisphere for that.
there is a total eclipse of the sun in Australia in 2028, and that gives you a two birds with one stone kind of scenario.
Yeah.
Um, So, we're back to a little closer to Earth. There's an experimental servicing mission coming up for a space telescope. NASA came up with a small amount of money, and I don't mean a very much money, $30 million, which sounds like a lot for a space mission. It's not. Um, and they gave it to a private company, which is going to maybe give NASA one of their space telescopes a new lease on life next year if all goes according to plan. So there's a company out of Arizona called Catalyst Space Technologies, which got a contract to raise the altitude of NASA's Swift Observatory, which has been hunting for gamma ray bursts from low Earth orbit for 20 years now. But because of atmospheric drag, it's starting to fall to Earth. And recent solar activity has accelerated that process. Um, so NASA tapped Catalyst to build a boosting spacecraft to remedy the situation. It's expected to launch towards Swift in the spring of 2026. And it's launching on a Pegasus, and it's an unusual launching platform because it's actually a Pegasus is flying on an L-1011, which is an old Lockheed Martin big plane. It is a missile that hangs underneath the wing. The missile drops, fires when you're very high up, the 11,000 meters plus, maybe 12, 13,000 meters. The missile drops and fires a rocket and flies into space. So it will be the last mission for the Pegasus and the last mission for the L-1011 drop plane. But then it will rendezvous with Swift, and then there's no way to connect to Swift. So they were quite ingenious. They come up with when Swift was launched, it was mounted on a booster rocket, on the upper stage of a booster rocket. So they've got little arms on this satellite to clamp on to the mounting mechanism that connected it to the satellite, and then it's got a motor which will fire and push the satellite up. Um, this is much cheaper, of course, than replacing Swift's capabilities, and thus beneficial to, I guess, the U.S. and NASA, but of course to science as well. Uh, this is a pretty big deal, and it could be a precursor to other possible rescue missions. So, as I said, Catalyst got 30 million to build the spacecraft via NASA's Small Business Innovation Research Program. Uh, they were already participating in that program, and there's a lot of things that could go wrong on this mission. It is highly experimental. But I'll say to you, if it succeeds, it opens the door to a lot of other possible missions. So that's some
Hubble,
NASA news.
the Hubble Space Telescope. Please save
Oh
Hubble.
yeah, I'm I'm all over it.
Yeah. That would be a very
Nobody,
different type of servicing mission to Swift because I think there's some other stuff that like Hubble is on its last reaction wheel and
yeah,
everything.
they'd have to, yeah, they'd have to replace the gyroscopes and
Yeah,
probably want to replace the imaging system, but
it's
maybe
Hubble.
it's
It's Hubble.
Hubble.
We're all attached to Hubble.
So And I think we've got one other little bit of news out of NASA as well, Suna, don't we?
Yes, which is the announcement for the Artemis 3 crew, which is going to be announced tomorrow at 11:30 a.m. EDT on NASA's website and their YouTube page. Very excited for that. Artemis 3 has undergone some changes to its mission plan recently. It's not actually going to go to the moon. It's going to be an Earth orbiting mission that will test out a variety of things, components of the spacecraft, particularly the docking with the lander that's going to take astronauts to the surface of the moon for the first time. So this will be a really, really important step in the longer term Artemis plans. Very exciting mission in general. So I will definitely be tuning in tomorrow at 11:30 a.m. to see who the Artemis 3 astronauts are.
And I will be tuned in as well. So, closing marks. It's time to close up for our podcast for this evening. Thank you for joining us. You've been listening to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Sue Withers and me, Paul Mackin. This podcast and past episodes are available wherever podcasts are distributed. You can also connect with us on Instagram at York U Observatory or on Facebook at Allan I Carswell Obs. Our website is yorku.ca/science/observatory. And there we have lots of interesting content. And if you feel so inclined, it's a great place to make a Canadian tax-deductible donation to our student-operated, not-for-profit observatory. Thanks for tuning in this evening. We wish you clear skies and a good evening. Enjoy the late